BelAZ 75710. Imagine a truck capable of carrying around 450 tons, the equivalent of hundreds of cars, and moving with that load inside a massive mine. This is the BelAZ 75710, one of the largest mining trucks in the world, designed to transport huge quantities of rock and ore. The truck is powered by two large diesel engines, which together produce about 4,600 horsepower. But the engines do not drive the wheels directly. Instead, the diesel engines generate electricity, which is then sent to electric motors that turn the wheels. This system allows the truck to move an enormous weight efficiently, even on the steep roads inside mines. The truck weighs more than 300 tons when empty, but when fully loaded, its total weight can exceed 800 tons. Its tires are also enormous, with each one standing several meters tall, making a person look tiny beside it. And despite this size and weight, the truck can still move at a practical speed inside the worksite and transport hundreds of tons in every trip. And so, the BelAZ 75710 is not just a large truck. It is a machine designed to move an immense weight in a place where ordinary trucks simply cannot operate. Big Muskie. Imagine an excavator weighing about 13,500 tons, carrying a giant bucket that could hold around 168 cubic meters of earth and rock in a single pass. This was Big Muskie, one of the largest dragline excavators ever built in history, and it operated in coal mines in the United States. It did not dig with an ordinary arm like the excavators people usually know. Instead, it threw a massive bucket far out in front of itself, then dragged it across the ground using enormous steel cables. As the bucket was pulled, it tore through huge amounts of soil and rock. Then the machine lifted it and dumped the load somewhere else. The bucket alone was so enormous that it was larger than many houses, and it could carry hundreds of tons of material in a single cycle. Big Muskie was powered by electricity and required an enormous amount of energy to operate the motors and cables that moved such tremendous weight. It was used to strip away layers of earth and reach the coal seams buried beneath them, changing the shape of entire areas of land as it worked. And so, Big Muskie was not just a large excavator. It was a giant machine that tore up the earth itself and moved hundreds of tons with every cycle. Taisun crane. Imagine a crane capable of lifting a load weighing more than 20,000 tons, the equivalent of dozens of large aircraft combined. This is Taisun, a giant gantry crane built in China for assembling massive offshore platforms. It stands about 133 meters tall and stretches between two enormous steel towers, allowing it to lift sections the size of entire buildings. In one of its most famous operations, it lifted a load weighing around 20,133 tons, setting a world record in heavy lifting. And the load was not just a piece of metal, it was an entire section of an offshore platform, lifted in one piece and installed into position. The crane relies on a massive system of cables and pulleys that distribute the weight across multiple points, allowing it to raise this enormous mass safely. The load rises extremely slowly because any sudden movement could cause thousands of tons to start swinging. That is why Taisun's power is not shown through speed, but through its ability to lift gigantic sections with precision, balance, and control. Giant forging press. Imagine a machine capable of applying a force equal to the weight of about 80,000 tons onto a single piece of metal. This is China's giant industrial forging press, one of the most powerful presses ever built by humans, used to shape massive parts for heavy industry and aircraft. A huge metal block is placed inside the press. It may be heated to extremely high temperatures so it becomes easier to shape. Then, the upper part of the press begins to descend slowly, pressing the metal with enormous force. Its dimensions and shape change without the metal being cut. With every press, the atoms inside the metal are forced to shift and rearrange, making the final part stronger and more solid. The press can shape massive components that cannot be manufactured using hammers or ordinary machines, such as parts for aircraft structures and heavy engines. Despite its immense power, the press does not work quickly. It presses the metal slowly and precisely until it reaches the required shape. And so, a massive block of metal, under the pressure of tens of thousands of tons, is transformed into a precise and powerful component used in some of the most advanced industries. Wärtsilä-Sulzer. Imagine an engine about 27 meters long, standing more than 13 meters high, and so massive that it looks more like a small building than an engine. This is the Wärtsilä-Sulzer RTA96-C, one of the largest and most powerful diesel engines ever built, designed to drive some of the biggest container ships across the oceans. The largest version came with 14 cylinders and produced nearly 108,000 horsepower, an enormous amount of power capable of moving a ship carrying thousands of containers. And it was not only massive from the outside. Each cylinder inside it was enormous, and each piston was so large that a person could easily stand beside it. The engine rotated at low speed but generated immense torque, enough to push a huge ship despite its weight and cargo. When fuel was injected into the cylinders and ignited, the expanding gases drove the massive pistons downward, turning their motion into rotation in the engine's crankshaft. This shaft was connected directly to the ship's propeller. The propeller then spun powerfully through the water and pushed the giant ship across the ocean. Baihetan Dam turbines. Imagine a massive current of water falling from behind a giant dam, then turning an enormous metal machine that generates enough electricity to power an entire city. These are the turbines of the Baihetan Dam in China, some of the largest and most powerful hydroelectric turbines in the world, with each unit producing 1,000 megawatts. Inside the dam, there are 16 generating units, which means the entire power station can produce 16,000 megawatts, an enormous amount of electricity. The idea begins by collecting water behind the dam, then forcing it through massive passages and pipes under immense pressure so it rushes at high speed toward the turbine. When the water strikes the turbine blades, it spins a giant metal wheel, turning the force of moving water into continuous rotational motion. This motion is transferred to the generator, which converts mechanical energy into electrical energy. The electricity is then sent to grids and cities. And because a single unit has a capacity of 1,000 megawatts, just one turbine can supply a large region with electricity, depending on the level of consumption. And so, this turbine does not burn fuel. It uses the force of water alone to power a giant machine that produces an enormous amount of energy.